So you've got the right time, right placement, right rate, and right source of nutrient application. In this case, they're targeting all fertilizers for this. And it makes sense, right? So we've got, it's the timing of when you put that down. And that's both for agronomics as well as for, preventing any type of a pollution event or any of that nature. So you want to make sure that you're putting it out not ahead of a big storm event, not when it's totally frozen and you get a little melt or a little moisture on top of that and it runs, or not when we're going to have our highest potential for having leaching events during the time of year, during your irrigation, etc. So the timing is very important. The rate obviously is also very important. You want to make sure that you're applying at agronomic rates, no matter what this is. There is a little bit of challenge with this versus a chemical versus a manure-based fertilizer, because with manure, sometimes when you apply at N rates, you're over-applying phosphorus and potassium on certain crops just due to the natural balance of manure. Nitrogen is a very sneaky little substance and it likes to move all over the place. I'll show a diagram of this, whereas things like phosphorus and potassium pretty much stay put. You're not losing those to volatilization to the air necessarily or leaching to the ground. They like to just stay right there on the surface. So you do have a little bit of a challenge when you're using manure versus if you're using a custom-based chemical fertilizer, you've got that recipe right up. But manure has a lot of other good things I'll talk about. Obviously the source, you've got different types of, you've got your chemical-based fertilizer, but then when we move to manures, particularly here on the east side, you've got liquid, you've got solids, you've got composted manure. It's all different. And each one, manure is not manure with all three of those. You've got different composition of nutrients in each one of those. You've got different release times. You've got different application methods. It's very different for each one of those. So selecting which one you use at the right time is also really important. And then, of course, the placement, making sure that it's on the right field, of course, at the right time, but more so that you're avoiding any type of high-risk areas on those fields. And at the end of the day, we're going to have a little activity that's going to test you on your knowledge based on that. We'll have prizes. So just FYI. So these kind of four, even though they're all, I think it's funny with the 4R is fine. It helps me remember them. So you sit there, which four are they? So right time, right rate, right source, and right placement. And when we look at manure versus chemical fertilizer, once again here, there is a little bit of difference. And manure itself, by the way, for the most part, is organic nitrogen and ammonium nitrogen. There's no nitrate in manure. When it comes out, there's no nitrate. This is really important, and I think most of you know this, but I want to nail that home. So when we're concerned about nitrate leaching on soils, for instance, and we were talking about this fall nitrate test, well, when does that happen? That happens in the soil. When you apply manure to the soil microbes in there convert this organic nitrogen and ammonium nitrogen to nitrate, which is what your plants mostly need. Some plants will use ammonium, and we'll talk about this later in one of our talks later, but that's a really important distinction, where when you apply chemical fertilizers, it could be whatever. You're using maybe urea, which is very easily transferable to nitrate. Maybe you're putting on ammonium nitrate. It could be a variety of different things. So what you put on for your chemical fertilizer matters. One really big distinction between these two is the availability of this product, of those nutrients to your plants. So with a chemical-based fertilizer, it's usually readily available, or the conversion rate's going to be pretty quick because there isn't a lot of extra things there. So you put on at different times of the year what's appropriate. If you're putting it on the fall and you want it to last in the spring, maybe you're putting an inhibitor in there so you're not having that conversion as fast. Maybe you're putting on more of an ammonium product so it's not readily available in season. Maybe you're putting on something available. With manure, you don't really have that choice as well. So you're putting on this mixture and you have to let the soil microbes convert that. When you apply when it's cold, let's say it's below 40 degrees Fahrenheit in your soil, those microbes are really slow. They're hibernating. This conversion rate is maybe just very minimal. Whereas when your soil is nice and warm and it's relatively dry, or you have I should say it's relatively moist when I talk about the east side here, this conversion rate can be a lot faster. So it could be 3 months in the cold winter months. It could be 1 month in the summer. So that makes a difference when we're thinking about that timing. When do you apply manure-based fertilizers? Liquid's going to be a little quicker, whereas your solids, especially compost, has a lot of carbon in there. and the carbon ties up that nitrogen. It's kind of holding it and bonding it. It takes longer for that to kind of come apart so that nitrogen becomes available for the soil microbes to convert to what your plants need. So the more carbon content or dryness, or you've got sawdust or wood, some kind of product in there, that's going to take even a little bit longer to break down. Your liquid manure is going to be the fastest. But oftentimes that's your parlor water. It's pretty darn dilute. So your nutrient concentration also matters. What has the biggest punch in there? So that's something, that's why you do manure testing, so you know how much nitrogen, phosphorus, etc. is in there, and how do I figure out how much I need to put on. If you're only at maybe 5 pounds of nitrogen per 1,000 gallons, your volume you put on is going to be a little bit higher. If you're at 20, which is probably pretty rare, but if you're collecting directly manure and it's not being diluted, you can be up at that mark. So your volume you put on to your crop is going to be a bit less. So those are really important to consider. Again, with the chemical fertilizer, you already know what it is. You put it on, it's always the same, and yada yada. So you just need a little bit more thought and work when you apply with the manures. Yeah, Tom?
How much is lost in the atmosphere?
I'll get to that in a minute. But let's just say on average, I'll answer that now and then get back to that. On average, let's say 40% is lost. And so it's either, looking at manure, it's either lost through volatilization, it's tied up in the soil, so it's immobilized. So about 60% of the nitrogen you apply is going to be available in some way to your crop. So that's a nice way. So if you put on 100 pounds of nitrogen, about 60 is going to be available in some way that during that time period. Some of that may come up a little bit later. Yeah, another question.
What climates make that higher or lower?
What climates?
What climates or yeah, what?
Oh, so what? So it's usually it's temperature, and for the air part, I'll talk a little bit about this later on today. But it's really factors like what is your soil moisture level. So, and that has to do with the microbes being able to convert things over. So if your soil is really, really dry or completely saturated, your soil microbes really aren't doing much, and you've got different rates of losses or tie-ups, etc. It's everything in the middle, which is where you're trying to keep your soil, and our irrigation talk will talk a little bit about that. But in that nice zone is where you're going to have the best biological activity in your soil. When it's really, really warm and dry, your volatilization or your air losses can be quite great. So you can lose up to 50% of the nitrogen you apply if you surface apply it when it's really warm, and we get a lot of volatilization. When you inject, that's a lot lower. In the next slide I'll show you kind of a little bit of the nitrogen cycle for our leaching and runoff rates. Those are completely variable based on this right here, how you manage this. You can have very minimal losses, or you can have great losses depending on what time you applied and what rate you applied and how you applied. So it's very variable. And then you've got that tie-up in the soil depending on the time of year. So things that matter the most are soil temperature and moisture level, and then air temperature are your three biggest for how we get the most amount of losses from that, for nitrogen in particular. So just a couple other things I'll kind of touch on here. The one good thing about manure is it's an amazing soil amendment. You probably have pretty low organic matter in your soils here. Manure is what builds that up. Sandy soils, manure is wonderful for bringing that in, allowing more soil moisture holding capacity, which is what a lot of your crops really need. So it helps with your irrigation. It's awesome. Chemical fertilizer does not add to soil health or soil tilth. And lastly, the one tricky thing about manure, less so here, but when we are concerned about runoff, manure does contain pathogens, chemical fertilizers don't. And those pathogens here, if you've got a manure exposed to moisture, or to air temperatures, to light, to a little bit of dry, a lot of that dies off pretty readily over here. So this is only an issue when you've got direct discharge. What Sherry kind of talked about is this is usually what they're concerned about. So just to touch on a little bit of the nitrogen phosphorus piece, and I'm just going to touch on these two because these are the two that are of most concern from an environmental standpoint. Phosphorus is a big concern because when it does get into waterways, it can create that green algae maybe you've seen. And so that's just hit and miss here and there. Most of the time it just builds up on our soils, and it's kind of to be determined what is the biggest problem with that. It doesn't really leach. Phosphorus is pretty much just lost by runoff issues. So when we get some soil moisture, you over irrigate, we get a big rain event, and you're getting sediment movement and losses off your field, most likely phosphorus is going along with that. So otherwise it just pretty much accumulates. It's nitrogen that is the most challenging because, as I mentioned, it moves around. It's everywhere. I mean, if your goal is to make nitrogen 100% available to your plant, you have your work cut out for you. It is really hard, especially with manure because of that lag time on conversion rate. But here's a very complex diagram. I'm just going to point out a couple little pieces about it. What I've circled are kind of the nitrogen movement pathways. And let's say we put manure on here, and some of that is going to come right down. Your microorganisms are going to convert that pretty readily, and it's going to come right back in your crop nutrients. This is kind of a closed system, and I wish it would stay that way, but it doesn't. That's just how it works. Some of this could be lost as runoff if that happens. Over irrigation, as I mentioned, or you get a rain event, something can create a runoff event. Or you get dust-blown soil, something of that nature. You may have a little bit that's lost in that way as well. But for the most part, your two biggest pathways of loss are as ammonia up into the air. If we get denitrification, meaning your soils get totally saturated or something of that nature happens, then you do get some loss as nitrogen gas. But that's pretty much more rare over here. So our main loss is as ammonia directly to the air, or if this nitrification happens and all this nitrate is not taken up by your plants, it's lost via leaching. So that's, as all of you have heard about this issue, I'm sure, the nitrate leaching to groundwater, that's how it happens, is that they're just, somehow the timing was off and the nitrate that's in the soil wasn't taken up by plants, and something pushed it down, whether that's rain or irrigation event, something had to push it down through the soil profile. How fast does that move? Who knows? So it could move at a rate of very little inches per year, centimeters maybe. It can move at a much more rapid rate. It really depends on your soil type, and we're going to get to that in the next talk here and talk a little bit more about that. So you do definitely, these are kind of your biggest movements up to the air or kind of lost to leaching, and hopefully all the rest stays in your soil profile and your plants are taking that up. Steve.
Nichole, is the volatilization ever considered a health hazard?
I'm going to talk about that, and it can be considered a health hazard. Whether that's real or not is very site specific, situation specific. You do have things, let's say you apply manure, and there are technically pathogenic potential in there, and if that immediately blows to someone who's standing right there and breathes all that in, that could be construed as a potential health hazard.
Is it just the pathogens, or is it to do with the nitrate?
It's not the nitrate. So the nitrate is only an issue when it gets into the groundwater and the levels are above 10 milligrams per liter. That's where EPA has drawn the line. Above that, it is a health hazard. Just certain people, young infants and the elderly, is where that's why nitrate in groundwater is an issue.
But because the ammonia concentrations are so dilute, it would not be
as an air. So nitrate does not go up into the air. It's only ammonia. And ammonia is only an issue from a health hazard standpoint, usually for workers in barns. Like, you have to be very high levels, right to it, exposure for 8 hours or more a day to have a health hazard. So for a neighbor, ammonia is not a health hazard. It's the levels are so low.
Even if there's an inversion over a geographic area?
Correct. Yes. So the only issue that could happen there is that ammonia, and I'll get to this again in the next talk here, ammonia can combine with other species in the air to create something called PM 2.5, which is also known as smog. And smog could be a human health hazard, again, for certain groups that are at more risk. Right, so, yeah.
What about the leaching of ammonium sulfate? Well, when they apply ammonium sulfate either on top or below the surface of that, and that converts over to nitrate, if the plant is not using that, or they put it on pre-plant can that take and convert right over into nitrate and leach down the same?
Absolutely. So when we talk about this, I don't care if you use manure or chemical fertilizer. I don't care how you get that on there. You're grazing. Nitrogen is nitrogen is nitrogen when it's in that system. And whether you apply nitrate, ammonium, or organic nitrogen, all three of those in some way are going to convert to nitrate at some point in that cycle. And whatever nitrate is not taken up by plants is potentially available to move down to leaching. So chemical fertilizers or manures, all the same once it hits the ground.
Can you distinguish between the two of them?
Like when you look at groundwater?
Yes.
No, you cannot. So the only way you could do that, it's very hard and very expensive and it hasn't been done, is you can do isotopic tracking if you've already done that on your farm. So it's, to actually take it from the groundwater and be able to distinguish the source is virtually, it's very, very, very challenging. It can't be really done.
Okay, what's the legacy? How long does ammonium sulfate stay there?
So that really depends on the conversion rate in the soil based on some of those other things I talked about. So that ammonium sulfate can readily convert. Hope that's the point, right? So when you apply that nitrogen, you kind of want it available for your crop at that time period. So it's probably converting pretty quick, which goes back to how much did you put on and are you matching that up with your crop needs? That's kind of that agronomic application rate calculation. So any fertilizer product over-applied or ill-applied at the wrong time can have an excess in the soil and be available for losses. Yeah, so it's not just a manure thing. This is any crop. Or any species of livestock. It can be your hops, farmers, berries. They're all equally responsible. If anyone uses fertilizer, they're all equally responsible for good nutrient management. And by nutrient, I just mean nitrogen, potassium, etc. That's what we're talking about. So this isn't a dairy issue. I'm just talking to you from a dairy perspective because that's the majority of the folks in the room. But that should also be known, and I know that's what's been missed a lot in this county with this issue currently, is that it's an equal issue for anyone who puts nitrogen on the soil surface.
Another critical element is the amount of water applied.
Yeah.
You could have the scenario where you would put less than what the crop is really using. If you put too much water on, you can still drive it down. So it's a relationship there that works together.
Mm-hmm. Absolutely, and we'll talk about that. And so a good way to talk about this is you need a catalyst to move things. So that catalyst in this case, to get, nitrogen is right where you apply it, and then it's just kind of in that top of the soil. So it needs something to make it move, and that's either irrigation, if not done correctly. And Troy hopefully will talk a little bit about how to get that done correctly so we don't have those losses. Or there's a big rain event or something, which is rare here. We don't get a lot of moisture here, but you may get one big event. You'll get like an inch sometimes, and that could push things. So it can take a really long time for something on the surface to get to groundwater, depending on how far it is down. If your groundwater comes up to the surface, where it does in some areas, that travel time's a lot less. So you've got this difference as well. So where you are, and when we talk about soils here in a minute, maybe you'll get an idea for that depth to water. That makes a really big difference as well. How fast is that traveling, and what's your even potential contribution? You could be, pretty close to zero. Is there ever zero potential for movement of nitrate to groundwater? No, that's impossible. There will always be a little bit of a leaky system, if you will. It just is what it is. So let's just work on helping you minimize any potential you may have to that. That's kind of the goal here with agronomic application rates. So hopefully that makes a little bit of sense. So I'm going to kind of wrap this up, and we'll move to kind of the next talk, which just keeps right on with this conversation. So this is great. But as I mentioned, I'm just going to now talk about a few of the challenges with manure, which I'm pretty sure I've already hit via your questions. But it's that nutrient availability. So when is that going to be available? So that matters when you apply it based on that time of year and what crop is growing. And it's very hard. I really wish I could give you a graph that said, all right, if I apply right now, today, it's going to be available on this date. Unfortunately, it doesn't work that way, because between that time period, it could get warm, could be a lot faster, it could be a lot slower, etc. So again, those soil testing really helps you kind of figure that out, when is it available, as well as hopefully your local kind of conservation district or planner or some guides can help you figure that out. We've got a few of those available on that website I showed you. And the manure type, as I mentioned, this makes a big difference about how much nitrogen is in there already and how long does it take to unlock that and get that available for your plants. This is going to be the fastest, and this is going to be the slowest. And that manure nutrient concentration, as I mentioned, this is going to vary throughout the year a little bit. If you get a rain event, if you're adding water to that because you're using it through your irrigation system for application, which lagoon you pull out of if you've got multiples. So that matters. That's why you need a test for each one of those sources so that you can figure out how much you're putting on. Again, when we talk about this issue about, well, can it leach and what about this? Well, if you don't know how much you're putting on there, you could be over applying. You could be under applying actually. So it's really to your benefit to have those tests and know what you're putting out there. And then that timing, and this matters too. This is sometimes a convenience issue, right? You're like, well, I've got to haul my manure to this one. I can't get through my line, so I'm going to do the close fields. And maybe you've got your heavier stuff or your more solid manure that you apply on those fields all the time. If that's the case, watch your phosphorus levels. Phosphorus isn't so much in the liquid portion, but more the solid fraction of your manure. So if you always go to the same field with your solids or the bottom of your lagoon, those phosphorus levels could likely be higher. So just the way to figure that, or to kind of work on that, is try to alternate those if possible. If you have to call a custom pumper, custom applicator, sometimes you're at their mercy of their schedule. So you may not get it out on that exact day you want. Maybe you are working with one rain event that's coming and, oh man, I'd like to get out before that. Well, it's actually better to wait and get it out afterwards so you're not getting a big push potentially of that down below your root zone if something of that nature. So you do have some challenges with manure in that case, but all of these are easily work around. It's just good that they're recognized and you can kind of think through these things a little bit.